Hello everyone. Now our second experiment to determine the work function of the given photometal and Planck's constant using photoelectric effect. So here first we need to write the aim which is given in the question. Second we need to write apparatus. First write in simple words. One is photosensitive device, light source, DC regulated power supply, and next is current detecting unit. Means here the photocurrent is detected. Next, draw the diagram and for connections, connect according to the diagram. Like negative voltage to the positive side of the this terminal, this photometal, negative side of the ammeter to the negative of the photosensitive device in this way according to the circuit diagram. Now, for this observation table, write all blue, green, orange, red color filters because for light we'll place all different types of color filters like one blue color filter, green colored filter, it is a disc shaped filter, and here we need to find frequency by using this formula in calculation, which is for frequency of blue light C by lambda we need to do. One is 3.3 into 10 power 8, which is same for all, and for lambda for wavelength, here we have wavelength which we need to remember. For red, wavelength is 640 nanometer. For orange, it is 570 nanometer. For green, it is 500 nanometer. For blue, it is 450 nanometer. So for blue, wavelength is 450 into 10 power minus 9. Solve it, you will get frequency of blue. In the same way, similarly, find wavelength for green, frequency for green, frequency of orange, and frequency for red. And then write in this observation table. Here you will observe that frequency will decrease. And in the same way, for potential after that we need to find. So first you write all frequency in the observation table. Then photocurrent will be 0 only. Because here we will find stopping potential. At the time of stopping potential, we will get photocurrent as 0 only. So first what we need to do is take a photosensitive device. After taking a photosensitive device, in the light emitting source, place a colored filter and switch on the light. Now light will emit and you'll observe photocurrent. Now slowly in negative potential, which is retarding potential, slowly increase the retarding potential. Retarding potential is nothing but the potential at which the photocurrent decreases. It will start decreasing its retarding potential. Now when you increase that retarding potential, means negative potential, then the photocurrent will decrease and decrease and decrease, and when you increase to the stopping potential, then the photocurrent is stopped completely. The voltage, the potential at which the photocurrent stops completely is stopping potential. So now at this stopping potential we need to find. Then photocurrent will be 0. Now you will vary the potential. Then slowly in microammeter the current will vary. In the same way as you increase the retarding potential, the microampere current photocurrent will decrease slowly. In this way, at stopping potential, the photocurrent will be 0. So for each colored filter, you need to find stopping potential. And in Viva, we might get a question that your frequency is decreased. Stopping potential also decreased. So frequency is directly proportional to stopping potential. The reason is h nu is equals to h nu naught plus half mv square max, which is kinetic energy. So h nu is equal to, this is work function plus electron volt, because this is kinetic energy can also be written as electron volt, which is stopping potential actually. So here this frequency nu and the stopping potential are both are directly proportional. So if frequency is decreased, stopping potential is also decreased. In this way you need to write an observation table. That's it. After that you plot a graph. While plotting a graph, this should be stopping potential values. Here we have all stopping potential. So this is all stopping potential that we will find from experiment. So that we need to plot in y-axis. In x-axis, we need to plot frequency. Frequency means this one we'll find right through calculation. This frequency we'll find through calculation. This stopping potential we'll find through experiment, practically. So in a y-axis, it is stopping potential. In x-axis, it is frequency. Plot, you'll get a straight line. And here, it is in negative side, you'll get work function. You'll plot a work function. So work function is the minimum amount of energy required to emit an electron from the metal surface. Means to start the photo emission, to start the photoelectric effect, the minimum potential is work function. Sorry, minimum energy is work function. Next, here you'll find a slope. By taking an arbitrary point from here, draw a line. Take an arbitrary point here, draw a line. Here take the coordinates of these 2 points and find slope. Find slope, but here for frequency remember to keep into 10 power 14. So you will get a slope value. This slope is h by e, because here h nu is equals to h nu naught plus half mv square max, right? It is in the form of y is equals to mx plus c. mx plus c. So c slope is h nu naught. Means h into c by lambda. Get cancel. Yeah. Wait. Just remember that slope is h by e. That's it. So it is 0. You will get slope from here, x point, y point, and x1, x2, and y1, y2, which is y2 minus y1 by x2 minus x1. From this, you will get slope. Now, this slope is h by e. So, h by e is equal to 0.33 into 10 power minus 14. So, here we will get this Planck's constant. So, from this, in result, we will write the Planck's constant in terms of joule second. After that, next is work function. Work function, here we got this work function from graph. Just directly write in the result. That's it. Now, I am going to explain Viva part. In Viva, what we are going to ask is first, I'll explain about photoelectric effect. In photoelectric effect, this is photometal. This is Q plate. This is applied potential. Here, negative potential is connected to the photometal. The reason is, in photometal, all electrons will be there. If negative potential is connected to the photometal, then electrons will repel and it will move towards the Q plate. Then photocurrent will increase. Because as the charge of the electron, movement of the electrons is there, then photocurrent will increase. Now here, before that, first if there is no potential, we all know that it depends on frequency of the incident light. If the frequency is increased, then photocurrent is increased. In that, the minimum frequency is threshold frequency. At this frequency, it will start the photo emission. After that, when you increase the threshold frequency, then electrons will move, photocurrent is increased. Now, if frequency is constant, then we need applied potential, right? Now, in applied potential, connect this negative terminal to the photometal so that this negative terminal will repel these electrons in the photometal and then it will move. It will repel, right? So it will move towards this direction. Then as it will move, as movement of the electrons take place, then photocurrent is increased. Now photocurrent is increased. Now when you increase this potential, increase, the photocurrent will increase and at some point of time, it will reach saturated photocurrent. Means After this photocurrent, it will not increase even if you increase the potential. So this is the highest photocurrent. Now, if you want to decrease the photocurrent, decrease IP, then simple trick is connect positive terminal of the voltage to this photometal. This is Q metal. When you connect this positive terminal of the potential to this photometal, this plus charge will attract this negative electrons, right? This plus charge will attract negative electrons and it will restrict the flow of electrons towards the Q metal. If number of electrons are decreased, photocurrent is also decreased. Here photocurrent is not stopped. Some photocurrent will be there. Means because here out of 100% only few percent of the electrons are passed. So photocurrent will pass but photocurrent will decrease. So this minimum potential required to decrease the photocurrent is retarding potential. Minimum potential required to decrease the photocurrent. Here the photocurrent is not stopped. Here it is decreased. Now if you increase this retarding potential, means if the positive terminal is increased, then more number of electrons are attracted by it, right? Then no electron will pass. Then IP current will become 0. So if the retarding potential is increased and increased and increased, at some point of voltage, the IP current will become 0. Because all electrons are attracted by this positive terminal. No electrons will pass. So this is stopping potential. Means minimum potential required to stop the photocurrent IP. And one more thing. We'll be having definitions in Viva. One is threshold frequency. Threshold frequency is the minimum frequency at which the electrons are emitted from the photometal is threshold frequency. Next is work function, is the minimum amount of energy required to emit the electron from the metal surface is work function. Next is retarding potential. Retarding potential is the minimum potential required to decrease the photocurrent. Stopping potential. Stopping potential is nothing but it is the minimum potential required to stop the photometal. So retarding potential, minimum potential to decrease the photocurrent. Stopping potential is the minimum potential required to stop the photocurrent. Next is formula. H nu is equals to H nu naught plus half mv square max, where W is equals to H nu naught. H is Planck's constant, nu is frequency of the incident light, nu naught is the threshold frequency, V max is the maximum kinetic energy of the electron. That's it. One more thing. If frequency is increased, kinetic energy is increased because H nu is equals to H nu naught plus half mv square max. So here frequency of the incident light is directly proportional to V max square, right? Means this is speed of the electron. If the frequency of the incident light is increased, then speed of the electron is increased. Means kinetic energy of the electron is increased. If the electron moves speedily, then photocurrent is increased. So if frequency is increased, then photocurrent also increased. That's it. All the best. Bye.